Alright, hey guys. Today we're going to be doing the Algebra 2 Regents from August of 2025. Okay, alright, number 1. What is the 7th term in the sequence -2, 6, -18, 54? So first I want to figure out which type of sequence we have. So is it arithmetic or geometric? So I want to see. First I want to check add. So this is plus 8 and this is minus 24. It's not consistent here, so let's see if we can find a multiple. So -2 times -3 gives me 6, and then 6 times -3 is -18. So this tells us that this is a geometric sequence, and my ratio is going to be r is equal to 3. And now to get the 7th term, we will have to use this formula. So it's a sub n is equal to a sub 1 times r to the n minus 1. So for geometric sequences, each of the terms, it's basically an exponential relationship. And this formula is actually given to you. It's towards the back of your test. During the test, you might be your proctor might ask you to just rip the sheet out, but it's given in this formula over here. And that would gives you the this is the explicit formula for a geometric sequence. And then now we just gotta plug it in. So my a sub 1, my first term, is -2. So my a sub 7 is gonna be a sub 1, which is -2, times my common ratio to the n minus 1. So I want to find 7 minus 1. And I'm just gonna, normally I would just recommend you to use your calculator to do this. You are given a calculator for this whole entire test, so I don't see why you would not do it. Minus 1, 7 minus 1, and I get a sub 7 is equal to -1,458, and that is choice 1. And that also kind of makes sense because every odd term is going to be negative. Okay, given x is not equal to 0, where mx is equal to 12x to the 8a power, and p of x is equal to 3x to the 2a power, the expression m of x over p of x is equivalent to. So I'm kind of find this fraction here. This is kind of I'm just doing a little bit of division here. So it's 12x to the 8a power over 3x to the 2a power. So when we have the the number part, 12 over 3, that's just 4. That part's very simple. And now this is related to exponent rules. So my x, this is the same base, and when I do that, when I have division, if the base is the same, I'm going to subtract the exponents. So this would be 8a minus 2a, and then this would be 4 times x. The power of a minus 2a is 6a, so I get 4x to the 6a, and that's answer choice 2. All right, and that's just testing you on the exponent rules. What is the inverse of f of x is equal to 2x plus 6? So if you're finding the inverse, how I like to think about it, inverse, I'm just switching my x and my y's. So what I like to do first is, instead of f of x, I want to write it as y equals. Just makes the process a little bit easier. And then now, finding the inverse, I'm just switching my x and my y's. So then this becomes x is equal to 2y plus 6. Again, I just switched my x and my y's. And now I want to solve for y. So then I'm going to subtract 6 on both sides. And then I kind of still have that 2 that I'm going to divide everything by 2. Or multiply everything by 1/2. So it becomes 1/2 x minus 3 is equal to y. And then instead of y, I'm going to use the inverse notation. F to the -1 of x is equal to this over here. And you'll see that that is answer choice 3. Okay. The expression cube root of 16x to the power of 6 is equivalent to, okay, so when I have this radical here, I'm going to split it up. Cube root of 16 times cube root of x to the power of 6. So this, I'm going to figure this out in a second. This one's a little bit, I personally think the number part is a little bit harder. This over here, this is just 6 over 3. So when we have something like x to the power of m, and then I'm taking the nth root, this is just x to the m over n. And then this is using fractional exponents to represent these radicals. And this will come kind of handy later. So I'm kind of just rewriting it in the fractional exponent form. And I can kind of simplify that. So this is just x to the power of 2. And then now this part is I want to break it up. So I kind of have an idea of how to break it up. I'm going to break it up into, actually, this is going to be equal to 2 times 8. And you know what I do know? The cube root of 8 is equal to 2. So if I split this up, this is cube root of 2 times cube root of 8. That's equal to cube root of 2 times 2. And with radicals, like you can have square root, cube root, whatever, you can kind of break it apart. And as long as it's multiplication, you can break it apart. Addition, you can't do that. Multiplication, you can break them apart. And that's what we have here. That's why I'm able to separate the radicals. So this, I can't find the cube root of 2. It's not gonna be a nice number to be dealing with. Yeah, and then I personally like to just rearrange that so I'm not confusing my indices and what goes underneath the radical. Okay, and now I'm gonna just put this back here. This becomes 2. And I'm gonna actually put the x squared in front. Makes it a little bit easier to see. So it's 2x squared times the cube root of 2. And that is the answer. That's answer choice 3. Okay. Number 5. Mary would like to determine if there's an association between a student's height and their shoe size. She measures the height and shoe size of every 10th person entering her school. This is an example of. So this is an observational study because she's like looking. She's like observing and kind of like just collecting data. She just want to find an association, all right? She's trying to find a correlation. She's not trying to establish like a cause and effect relationship. So this is not a census. You're not kind of like collecting data about like the census that the U.S. takes every like 10 years. They come around, see like who's in your family. That's not really what we're dealing with. A simulation? No, it's not a simulation. She's not simulating any events. And a control experiment? No, because she's not like actively like changing anything. A control experiment is used to establish some sort of like cause and effect relationship, but then that would involve the experimenter to actively like alter one of the variables, the independent variable, and trying to see if there's an effect. But she's not altering anything here, so no. Okay, for all values for which the expressions are defined, which expression cannot be rewritten as x minus 6 times x plus 2. Okay, so let's look at choice 1. Over here, I'm gonna, I think, so actually not I think, but this quadratic here is factorable, and just factoring trinomials, and this one, it should be kind of easy because there's nothing in front of the x squared. The leading coefficient is 1. So just find two numbers that multiply to negative 24 and add up to negative 2. And the two numbers I'm thinking of are 4 and 2, and then 6 takes the negative sign. So this becomes x minus 6, and then x plus 4. And all divided by x plus 4. And then you can see that this cancels out. And then we're just left with x plus 2 times x minus 6. And you'll see that's equivalent to what's given to us in the problem. All right, let's look at choice 2. So x times x plus 2 minus 6x plus 2. All right, here I'm going to factor by GCF. So my greatest common factor is x plus 2. So I'm going to take that out from kind of like both of my terms, both of them here. And then now for my first term, I'm left with an x. So that's where it goes. And then for my second term, I'm left with a minus 6. And then after this factorization, I'll see that I get something that's equivalent to the expression given to us in the problem. So it's not that. Okay, for this, choice 3. Okay, so I'm gonna make myself some space here. So for this, I'm gonna try to factor this. So x minus 2, I want to find two numbers that multiply to negative 12 and add up to negative 4. I'm thinking of 2, 6, and the 6 is going to take the negative sign again. So then this becomes x plus 2 times x minus 6 over x minus 6. And then we'll see this cancels out. And then this would equal to x minus 2 and then x plus 2. And you'll see that that does not match up with whatever's given to us in the problem. So the answer is choice 3. To be safe, I would also test 4, and test 4 is the kind of like the more tedious one. Choice choice 4. That might be the more tedious one because factoring that one is actually going to be a little bit on the more difficult side because you have to first expand it and then combine like terms and then factor it. All right, I would try to do the other ones first. Like, doesn't matter what order the answer choices are in, you're probably not going to see in this order maybe, but I would just try out the other choices first and kind of like use, like kind of like process of elimination if I'm able to eliminate the other choices, but the choice I can't eliminate, then that has to be the answer. So yeah. Okay, the number of hours in the lifespan of a certain brand of light bulb is normally distributed. So this is keyword here. With a mean of 2,387 hours. So my mu is going to equal to 2387, and a standard deviation of 238 hours. So my sigma is going to look something like this. Is 238. To the nearest tenth of a percent, what percent of light bulbs have a lifespan of greater than, so I want greater than 2,750. All right, so we're gonna use this function. This is kind of like the only function that like you have to know for the algebra 2 regions. You're gonna go to stat, and not stat. You're gonna go press second, and then you're gonna press vars for distribution, and we're gonna go to normal CDF, and then my lower. So I want greater than 2,750. So my lower bound is gonna be 2,750. And then my upper, so technically it's more simple like infinity, but I'm just gonna pick a really, really big number. So I'm just gonna hit a bunch of zeros. And then my mu, which is my mean, it's given to us by the problem, is 2,387. And then my sigma is 238. And then I'm gonna paste it, and then it's gonna do a little bit of calculation for me. And since I wanted it in percent, I'm gonna multiply it by 100, and I'll get that it's about 3.4%. All right. Here I'm using the normal CDF function. So what the normal CDF function does is that, let's say this is the normal distribution. It's basically gonna find like the probability. It's the cumulative distribution function, so kind of like it just accumulates. So it's just gonna keep taking the area underneath the curve, and like for a specific region. So I kind of like did that bad example because it's greater than 2,750, so it should kind of like take the area of like this over here, and it will give us like a percent. The here is actually going to be less. I just looked at the answer and realized that. Yeah, so that's what the normal CDF function is. Usually you're going to see one of these questions, you might see it on the free response section, and for free response you would just type in the calculator line. All right, maybe for like your big number you don't have to be like that overkill with like that many zeros. Just pick a big number and then just write it in, and that's a valid way to show your work, and because you use your calculator there's not much more that you can do. Okay, number 8. So the solution set to the equation 2 over x cubed plus 1 over x is equal to 6 over x cubed. So this is we have a rational equation over here and we want to solve. So first I want to mention that we have a kind of like a domain problem here, which is x cannot equal to 0, because if x is equal to 0, we're going to be encountering a problem with dividing by 0, and that's no good. So we can't have any 0. 1 and 4 could be eliminated. Okay, I'm just gonna do this. So let me just write this down first. How I like to solve rational how I like to solve this is that I'm gonna multiply everything by the kind of like the least common denominator. In this case, it's easy for us to see. It's just gonna be x to the power of 3. But then if you're struggling to find the least common denominator, you can just kind of like just multiply all of the denominators together and multiply every term by that product. But in this case, we actually have it easy because this is just x to the power of 3. So then you'll see some cancellations. So for the first term over here, this just becomes 2, and then this becomes x squared. So if you remember exponent rules, and then the on the right hand side, that just becomes 6. And this is pretty easy to solve. This is just x squared equal to 4, and then when we take the square root of both sides, make sure we take the plus or minus. All right. So answer is either 3 or 2. So your last step, just to be safe, I would recommend plugging in both of those answer choices into the back into the original equation. I would do that for rational equation. So when you have like fractions, you have like variables in like the numerator, the denominator, I'll do that, especially in the denominator. And I also do it for radical functions. Usually it's like square root. So I'll just plug it back in, and I can let you know. After plugging it back in, I verify the equation, and both of the solutions work. So it's answer choice 3. Okay. Number 9, what is the solution to 9 times e to the x minus 2 equals 36? And one thing that I noticed over here, this x is actually supposed to be italicized. Yeah, okay. So 9 times e to the x minus 2 is equal to 36. So first, when I'm solving for like any like for a variable, I want to get that variable, like I want to get rid of as much as the things attached to it. First, I think the easiest thing to get rid of is that 9. I'm gonna divide both sides by 9. So then this becomes x to the e to the x minus 2 equals 4. And then now, in order to kind of like undo this exponential here, I'm gonna take the log of both sides. Specifically, I'm gonna do the natural log, ln. So then now, if I take ln of both sides, I can bring down the x minus 2, and then this is going to be times ln of e. And then ln of e is just 1, all right, because ln, so ln is equal to log base e, all right? Of course, you will have like some argument here, but yeah. And then if you just have log base, let's say log base e of e, that's just going to be 1, because e to the first power is 1. Okay. So then we have x minus 2 is equal to ln of 4. So that means x is equal to 2 plus ln of 4. And then I would plug that into the calculator. So 2 plus ln of 4. And I get x is equal to 3.386. Oops. Just a little bit of handwriting. Oh. Okay, I lied. Do not need to plug it into calculator. The answer is choice 3. Okay, all right. Renato got a score of 40 on his first test. If he gets a score of 100 on every additional test, which equation can be used to determine the additional test x he would need to take in order to raise his test average to an 80? So now I'm trying to model this equation using sort of like some algebraic equation. So I want to figure out how to find the average. So when I'm taking the average, I want the sum over kind of like the quantity. All right, so the sum of the scores. So he got a 40 on the first test, and then 100 on every additional test. I would do plus 100 times x. That would give me the total score. And I'm going to divide it by the number. So x is the additional test score, so you have to be careful here. I would actually divide it by x plus 1, because x does not include that first test. And then this will equal to 80, because I want the average to be 80. So the answer is choice 1. Okay. Given f of x is equal to ln of x plus 5, what is the smallest integer value of x for which f of x is defined? So we can't take, so for ln, there's the domain restriction. We can't take ln of a number. So let's say we have ln of x. X cannot be, x has to be greater than 0. It cannot be, it can't be 0. It can't be less than 0. So I'm going to use this fact for ln of x plus 5. And that means x plus 5 has to be greater than 0. So x has to be greater than negative 5. It's the smallest integer. But notice, this is not inclusive, all right? Negative 5 is not included. So now that is going to be negative 4. That's the next smallest integer, all right? You can kind of see negative 1 and 0. They are bigger, but it's not the smallest one. So, yeah. Okay. Which expression is equivalent to this jumbo here? So what I like to do for this is long division. I think I don't really like using synthetic division except for when I have something like x minus a. There's something in front of the x, it's going to add an extra step. So I might as well do long division, and long division works for everything. So the thing that I really want to focus on is the kind of like the leading term of my divisor, so 2x. And I'm kind of going to just go like through each and every single one of these terms to help me figure out. So first, let's look at 6x cubed. I want to see how do I go from 2x to 6x cubed. I will multiply by 3x squared. 3x squared. And then this would be 6x. So I'm going to just multiply this out. So then this would be 6x cubed minus 3x squared. And I'm going to subtract it. So this is kind of like just like doing it's very, very similar to doing long division related to like just regular numbers. All right, I'm going to subtract. So then this, as expected, this should cancel out. And I have 7x squared minus negative 3x squared. So I put a parentheses here because I want to remind myself that I'm also doing the subtraction for the second term. I'm not adding it up. So yeah, if I'm subtracting a negative number, I'm adding it. I hope that didn't confuse you. But yeah, so 7x squared minus negative 3x squared, that would be 10x squared. And now I bring this down. And then I'm going to repeat. So 2x, how many times does it go into 10x squared? It's just 5x. So then this becomes 10x squared minus 5x. And then I subtract again. And then this becomes minus 4x. I bring down the minus 1. And then, oh god, I don't have enough space because I got to deal with remainder, I think. Okay, I hope this is enough space now. And then this would be minus 2. So minus 4x plus plus 2. And then when I subtract, I'm gonna get minus 3. So then this would be minus 3. So then to express the remainder as part of the quotient, I would just do minus 3. So because it's negative 3 over the divisor. So then you'll see this is answer choice 4. Okay, a sketch for p of x is shown below where a is greater than 0 and b is greater than 0. Usually by the region where I've noticed that p of x, they tend to use p of x for polynomial, p for polynomial. Okay, where the and then now I want to see kind of like what the equation is. So here, this b, right? This would be x minus b. Here, this would be x plus a, and yeah, but the kind of like the problem is the multiplicity. Do we know what it is? So first, by looking at the end behavior, when we go from like when x approaches infinity versus x approaches negative infinity, they approach different things, and that would mean that the end behavior is different. So that means the kind of like the degree of the polynomial is odd. This is an odd polynomial. And then now this, so for at negative a, kind of like the polynomial bounces off from the x-axis. That would tell me that m is even because it bounces off. And then for when it's at b, it goes right through. That means n is going to be odd. All right, so then looking at my answer choices, the only one that satisfied the description that I just gave is answer choice 2. Okay. If f of x is equal to 1/2 x cubed plus 3x squared minus 4x, and g of x is equal to 5 log base 3 of x plus 10, then which value rounded to the nearest tenth is not a solution to f of x is equal to g of x? So for this one, this will require you to use your technology. Do not know why this does that. Oops. Okay, so I'm going to press y equals, and now I'm going to put f of x into y1, my first equation. X cubed plus 3x squared minus 4x. And then for g of x, I'm going to do 5. And then to get log, I'm going to do, so on the auto calculator, you have to utilize the change of basis. For your log, you're going to have to do like log of like, you have to just do like log of x plus 10 over log of like 3. And yeah, and then for this one, you're going to, you can just use the built-in function, which is you go press math and then you just go all the way down. You use like I use the up button to go all the way down, and you see log base, and then you can just do log base 3 and then x plus 10. And then let's graph it, and as expected, I'm gonna need to adjust the window a little bit. I'm gonna just go up a little bit so I can gonna make the y max a little higher. Let's pick 30. Okay, I see 3 points of intersection. So that's a good sign because I have 4 answer choices. So 3 of them probably intersect, right? So let's check each individual one. So I'm gonna press second, calc, and I'm gonna go down to intersect. And then now first curve doesn't really matter. You don't really gotta touch any button. The last part is where you touch it. So you wanna scroll all the way over. Let's guess. Okay, this is negative 9.4. So we can eliminate choice 1. Let's do it again. Second calc and then intersect. And then I'm gonna actually do it here now. Okay, negative 1 point. So that's not that. And then the last one, second calc intersects. I'm gonna move over here now. So your first curve, so the step is first curve, second curve, and then your guess. So you can move the cursor anytime. It doesn't really matter. Like when you do the curve, it doesn't really matter because like you just identify which curve it is, and no matter where you are, whatever your x is, the curve is still gonna be the curve. So it doesn't really matter. It's 2.2. So the answer is choice 4. That's not part of the intersection. Okay. The graph of f of x is shown. Which graph represents f of x plus 3? Okay. All right. You have to notice what type of transformation here. So here, we have some function here. When we have it inside, like how I like to remember is if it's being like added directly to the. Actually, before I say that, I'm adding a number. So this is a translation. All right, it's not gonna be like a dilation. It's not gonna be a reflection. But then now is it like vertical, like up and down, or is it horizontal, left or right? So here's how I like to remember. Since it's being done directly to the x, it's gonna be horizontal, so it's gonna be left or right. And then now horizontal, this one's a little bit funky because for horizontal, it's actually a little bit counterintuitive. So x plus 3, we usually associate right with plus, but then when we have horizontal, it's kind of the opposite. So it's going to be left 3 units. All right, and why that is, it would take a little bit of explanation to understand, but kind of like the very, very brief summary is that you're basically undoing something. So yeah. The answer is choice 4 because if you compare the graph in choice 4 to the graph given by the problem, graph 4 is just 3 units to the left. Okay, what is one solution to the system of equations shown below? This one's a little bit of algebra for this one, and if you recognize it, here we have a circle intersected by a line, and we might have 1 solution, 2 solution, or 0 solutions. Okay. So for this method, what I'm going to do is I'm going to use substitution, and I think that's the easiest. So I have the equation of the circle, x squared plus y squared is equal to 20. And I know that y is equal to x minus 6, so I'm going to just substitute that in. X minus 6 squared is equal to 20. So then x squared plus x squared minus 12x plus 36 is equal to 20. So I'm just doing the expansion here. I'm going to just combine like terms. So this becomes 2x squared. And I'm going to move the 20 over. And why I did that? Because I want the quadratic to be equal to 0 when I'm solving it. And then I'll see that I can divide everything by 2. So x squared minus 6x minus 8 is equal to 0. And now this is a factorable equation. X minus 2 times x minus 4. So again, the process is finding two numbers that multiply to negative 8 and add it to negative 6. And negative 2 and negative 4 were the two numbers. That's my procedure. And then if I set each of the factors equal to 0, so x minus 2 is equal to 0, that means x is going to equal to 2. And then x minus 4 is equal to 0, that means x is going to equal to 4. So I have my 2x's here. Okay, so the intersection is going to be a point, so not really a line. So not that, not that. And then now I have to see, okay, they both have a 4 in common. So you know what I'm going to do? I think the one that we're going to be focusing on is the x equals 4. Again, there's going to be 2 points because I have 2 x's. Now I'm going to plug it into either one of the equations to solve. I think plugging it into the second equation would be easier. So I'm going to use the second equation. So y is equal to x minus 6. Y is going to equal to 4 minus 6. Y is going to equal to negative 2. So one is going to be negative 2 for when x is equal to 4. Okay, all right. Number 17. At high school, 10th grade students were recently asked if they walk to school and they eat breakfast. The survey results are summarized in the table below. What's the probability that a random Least selected 10th grade student from the school walks to school or eats breakfast. So for walks to school, we have these students over here. And then for eats breakfast, we have these students. So to find the probability, I want to find kind of like the number of like the one that like I want over the total number. So these are the people that I want. So it's going to be 10 plus 7 plus 53, which is equal to 70. And then the total number, so all this is 70. So all this combined is 70, and I just got to add 30. So my total is going to be 100. So then that means my probability is going to be 70 over 100, which is equal to 0.7. The answer is choice 2. Okay. A vehicle's depreciation rate, the value is going down, is 9.2% per year. If the vehicle costs $34,950, then which recursive formula models the value of the vehicle n years after it was purchased? So what they always like to do is they like to give like to test you on whether you know the difference between like recursive versus explicit. So recursive means that you're going to be defining the nth term using the previous term. So that's explicit doesn't depend on like the previous term. You just straight up returns it. So my a sub 0, that's gonna be my starting value, and both of them is the same, 34,950. Then now I'm gonna have to figure out kind of like my formula. So the depreciation rate is 9.2% per year, so that means it's gonna decrease. So the general kind of like thing that I want to think about is 1 plus minus r, the rate, and then times kind of like what it was previously. So a sub n is equal to 1 plus or minus the rate times the value from the previous year. So here it's actually going to be minus here because it's depreciation. My value is going to go down. And then my rate, I want to express that in the decimal. So then this would be 1 minus 0.092, and then n sub n minus 1. And then you'll see that since I'm subtracting, I'm going to get a number less than 1. Answer choice 4. You don't even have to like do the subtraction here. Okay. When factored completely, 3x minus 1 squared minus 5 times 3x minus 1 plus 6 is equivalent to. So when I have this here, some people, they might struggle to do this factoring, but I have a trick that makes it really easy. So let's let 3x minus 1 is equal to a. All right, see that b squared. This is 5a. Now this is easier to factor. Two numbers that multiply to 6 and add to negative 5. I'm thinking negative 3 and negative 2 and negative 3. A minus 2 times a minus 3. And now I'm going to do the substitution. I'm going to substitute back in. So 3x minus 1 minus 2 times 3x minus 1 minus 3. And then this would be 3x minus 3, 3x minus 4. But we're not done yet. For my first factor, I can factor out a 3. It says to factor completely. So then this will be 3 times x minus 1 times 3x minus 4. So the answer is choice 3. All right, make sure you factor completely. GCF is very, very important. Okay, given E of t is equal to 26 times 2 to the t over 20 represents the mass in grams of a substance after t minutes. Units are very important in a laboratory. Which statement or statements must be true? So the initial mass of the substance is 26 grams. Yes, that's true. The number that's being attached in front is always your starting value. So this is true. We can eliminate choice 2 then. The mass of the substance doubles every 20 days. So close. Not 20 days. It should be 20 minutes. So here we have an exponential growth over here. And that means I'm going to multiply 2 after every certain amount of time. And how I know that time? Since t is divided by 20 minutes, it's going to be every 20 minutes. So I'm going to multiply by 2 every 20 minutes. That means it's doubling every 20 minutes, not 20 days. 2 is incorrect. The mass of the substance after 3 hours is approximately 29 grams. So again, this is given to us in hours. We have to convert it to minutes. 3 times 60, that's 180 minutes. So now let's use our calculator and see. 20 times 2 to the 180 divided by 20. That is 13312, and that's not 99. So no, the answer is just choice 1. Okay. For x is greater than 0, which expression is equivalent to cube root of 9x squared times square root of 9x? So here it seems like we're dealing with rational exponents, and I've kind of like gave you the rule before. So this, I'm going to rewrite it as 9x squared to the 1/3 power times 9x to the 1/2 power. And this is the square root. As a reminder, if there's no index over here, we're going to assume that's the square root. So now I can kind of like distribute the exponent. So there's 9 to the 1/3 times x squared to the 1/3 times 9 to the 1/2, and then x to the 1/2. Okay, 9 to the 1/3. We can't simplify that. Actually, I don't think that's what we're supposed to do. I'm going to just kind of like arrange them together. And this over here, I'm just going to multiply it out. And this is x to the 1/2. Again, I have the same base, but different exponents. So I'm just going to add up the exponents. 1/3 plus 1/2 is 5/6. And then 2/3 plus 1/2 is 7/6. So the answer is choice 4. Okay. All right, the number of people who have read an article grows exponentially throughout the day and can be modeled by the function 2 times 1.098 to the power of t, where t represents the number of minutes since the article has been posted. Which equation best represents the number of people who have read the article in terms of growth rate per second? So first, the units. All right, I want to do it per second. So there's 60 seconds in 1 minute. All right. So I want to find the kind of like the rate for when it is like kind of like per second. So I'm going to set t equals to 1/60 because t is in terms of minute, and 1 second would be 1/60 minutes. So let's just plug that in. So this would be 1.00. So again, like I mentioned before, the number in front, that's my starting value. I'm not going to really care about that yet because the 2 is going to stay consistent. I'm worried about kind of like my base, what that rate will be. So I'm going to do 0098 to the 1/60 because I'm plugging in t equals 1/60 minutes. Let's get this. So I get 1.00012 162,551. So it's not 3 or 4 because that rate is different. And then now whether I multiply it by, do I multiply it by 60 or divide the by 60? So t is in minutes, and then in order to get minutes to seconds, I would have to multiply by 60. So I would use choice 2. So this is wrong. This is wrong. So yeah. Okay. Which equation represents a parabola with focus 2, -5 and directrix y equals 3? So what I like to do for this type of question is kind of like make a very, very simple sketch. Let's say this is 2 and this is -5. So this is my focus, and then my directrix is at 2. This is my directrix. So I'm going to expect my parabola to look something like this, right? So my parabola is going to open in the direction of the focus, and the vertex is going to be halfway in between the focus and the directrix. So then, like I just said, it's halfway, so we can find the vertex. So here we have a regular, so-called regular parabola. It just opens up or down. My x-coordinate is going to be the same as the focus, so it's going to be 2 comma something. And the y-coordinate is going to be the average between the y-coordinate of the focus and the directrix. So let's take the average of -5 and 3. -5 plus 3 is -2, and -2 divided by 2 is -1. So my vertex is at -1. And we can kind of eliminate choice 3 because my x-coordinate is wrong. So when we have a regular parabola, one way to express parabola when we're dealing with like the focus and directrix definition is x minus h squared is equal to plus or minus 4p times y minus k. All right, so my hk, that's my vertex. So this is my vertex, and then it's going to be x minus 2. So 1, 2, and 4 satisfy that. And then now y minus k. So then I would have y plus 1. So choice 1 is not it. Oh, wait, no, sorry, that's not what I'm going to say. Choice 2 is not it, because this is y minus 1. And then now is it choice 1 or 4? So the parabola opens downwards, so it would be negative. It would be 1. And then where we get that p-value, so that p-value is my distance from the, is this distance over here, or distance over here. So these two are both p. It's either from the vertex to the so it's either vertex to the directrix or vertex to the focus, or the distance from the directrix to the focus but divided in half. And the distance that I'm talking about here is assuming the shortest distance. So here my p would actually be 4. So then 4 times 4 is 16. That's how I got the 16 over there. Okay. All right. Which graph shows a fourth degree polynomial with exactly 2 imaginary roots. So according to the fundamental theorem of algebra, the number of roots, all right, whether it's real or imaginary, corresponds to the degree of the polynomial. So fourth degree means I'm going to have 4 roots. And now I got to classify them. Are they real or are they imaginary? So I have 2 imaginary roots. And imaginary roots always comes in pairs. Just letting you know. It can't be an odd number. It has to be 2. And then if I have 2 imaginary roots, that means I'm going to have 2 real roots. Okay, so here is what I'm looking for, 2 real roots. And then now, this is 4th degree. So that means this is an even polynomial, it's an even degree polynomial. I don't know if it's an even polynomial, like an even function, but I know that it's an even degree. That means same end behavior. Same end behavior. So they both better point in the same direction. So if we look through all the graph, the one that matches the description is choice 1. Choice 2, they do have the same end behavior. That's good. But the red flag is that there are too many x-intercepts. That means there are 4 real roots. All right, I'm only looking for 2. And then for 3, the end behavior is different. So this is an odd degree polynomial. And here, well, it also has 2, but this has a multiplicity of 2, and it wouldn't really make sense. So no. Here, 4 is not correct. This, first of all, looks like a parabola. But the end behavior is same. It's good that this is even degree, but there's no intersection with the x axis, so it doesn't have any real roots, right? So yeah, that's part 1 of the algebra 2 regions. All right, hope that helps.